Hey everyone, I hope you're doing well. In this video, let's go over some review on some integers and rational numbers, focusing on the coordinate plane. So this is just going to be sort of an answer key or an explanation to each of these practice problems. Alrighty, so let's take a look at number 1 here. It says, what is the horizontal number line called on a coordinate plane? If you'd like to pause and think about it, go for it. Otherwise, I'm just going to go ahead and write it and talk about it. So that horizontal number line, that's that line that's going left to right. That's called the x-axis, okay? It's the number line going left to right, kind of just like this. To the left, it's going to the negative infinity, and towards the right, it's going towards positive infinity, all right? For number 2, let's take a look at this one right here. So what is the vertical number line called on the coordinate plane? So think about it, that would be the y-axis. And that's that vertical number line, the one that goes straight up and down. And going up, it's going towards positive infinity, and going down, it's going towards negative infinity. All right, so that's first 2 problems, just a little bit of background. Number 3, what is the location called? So we're looking for a location where the horizontal number line, we're going to find when that meets the vertical number line. So that only happens in one particular location. So here's the vertical number line, here's the horizontal number line, and they meet at this location right over here, saying, what is this called? This is called the origin, okay? When you say the origin, that's going to be located at the point 0, 0. The x coordinate 0 and the y coordinate are both 0, all right? So there's 1, 2, and 3 so far, a little bit of background. And here's number 4. For number 4, it says, which quadrant has positive values that are y? So the y values are positive, and then negative x values. So if we're writing an ordered pair, it has negative x values, so it's negative first and then positive second. So be sure to write the x1 first and the y1 second. X is going to be this first one, and then y is the second one. Just keep that in mind. So think about which quadrant that would lay in. So if we just take a look at what the quadrants are, try to remember here that we have quadrant 1, and then 2, and then 3, and then 4. They're going around in that order. And where are the ones that are negative then positive? So negative first, then positive second. So we're going to go ahead and say for this that the answer would be in quadrant 2. Okay, all the points in quadrant 2 are going to be negative x and positive y. Let's take a look at number 5. Number 5 says, which quadrant, again, we're looking for another quadrant, has the positive x values and then negative y values. Okay, so let's see, the x values are going to be positive, so it's positive first, then it's going to be negative second, and we need to take a look. I'm just going to go ahead and copy this and then get rid of these. Whoops. I don't know if I can get rid of that one without getting rid of that. I'll redraw that one right there. And so how do we get to a positive then a negative? Well, positive on the x means we go to the right, and then negative on the y means we go down. So this would be in quadrant 4. All right, so there are the first 5 problems. Let's keep on going. Number 6, let's give this a try. Again, if you'd like to pause and try it on your own, go for it. Otherwise, we can do it together. Which quadrant has negative y values and negative x values? Okay, so we're going to have, let's see here, a negative and a negative. So if we go ahead and take a look, where would negative be? I should have copied the one that it doesn't have there. I guess this is the last one, so it doesn't matter. So negative x means we go to the left, and then negative y means we go down. So this point would be located in quadrant 3. Cool. Alrighty, here's number 7. Ooh, weird check mark there. Let's try that again. All right. Using absolute values, find the distance, how far apart. We have these 2 points of A, and then we have B, and then we're going to verify this with a sketch, okay? So let's see. If we take a look at A and B, I'm going to go ahead and rewrite those here. For A, oh my goodness. Let me move my phone away. Sometimes that keeps happening. Let's try this again. For A, we have -5, comma, -2. And for B, we have 7, comma, -2. So check to see what matches here. It looks like these are the matchy numbers, right? And so what doesn't match are these -5 and +7. So since they're in different quadrants, how do we write this using absolute values? Well, we're going to say the absolute value of this first number well, let's write the one further first, is going to be 7. And since they're in different quadrants here, what we're going to do is we're going to add their absolute values. So we'll go ahead and add the absolute value of -5. Remember, it's either going to be adding their absolute values or subtracting them, okay? So the absolute value of this 7 here is going to be 7, and the absolute value of -5 is going to be +5. So 7 plus 5, that's going to be 12, and the answer here is going to be 12 units, okay? It does say verify with a sketch, so we can go ahead and draw a rough sketch here. So, whoops, it doesn't have to be perfect, okay? So let's just try to make a rough sketch here. I think I could draw that a little better. Something like this. Okay, so where's the first point? A is -5, so 1, 2, 3, 4, 5, and -2. Again, very rough sketch here. Here's A, and then B is going to be located at 7, so 1, 2, 3, 4, 5. Make a couple little adjustments here. Put that here. 6 and 7, so we'll put B located right over here. So how do we verify this using the sketch? Well, from here to here, pretend that's perfect. That's going to be 5 units. And then if we go from here to here, we have another 7 units. So it makes sense to add these and not subtract them, especially because they're in different quadrants. Okay, so a total of 12 going across. Let me just mark that down here. So that's 5 and that's 7, so all the way is going to be 12. There we go. Okay, moving on. If you'd like to try this one, go for it. We're going to use absolute values again, but slightly different problem, just because we're going to find the distance between 2 points, but you're going to hopefully notice that they're in the same quadrant, right? They both have positive y values and negative x values. And then we're going to verify this with a sketch just to back ourselves up so we know we did this well and did it right. Okay, so C is located at -4, comma, +9. And D is located at -4, comma, +1. So what are the matching numbers? The matching numbers are these -4s here. And so we're going to find the distance between 9 and 1, but they're in the same quadrant, right? So what are we going to do with their absolute values? Think about it. If you were thinking we're going to subtract them, then you are absolutely right. I don't know why I wrote that. I did the opposite of what I was thinking. Oops. All right, so 9, absolute value of 9 is 9, absolute value of 1 is 1, 9 minus 1, that's going to be 8 total units, okay? Verifying this with a sketch, I'm going to go ahead and make a rough one here. Looks like I have to go to 9 up, so I'll try to make my spacing a little smaller so I can fit it. So here's my x-axis, here's my y-axis. -4, I'll go 1, 2, 3, 4, and then +9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So something like this. And for D, we'll go to -4, but we'll go to +1. So here's D. So measuring this distance between 9 and 1, this is going to be 8 units, okay? So we're just going to go ahead and make sure we subtract 9 minus 8 to get 1, or we can count those spaces. Cool, so that verifies that these 2 points, C and D, are 8 units apart. Okay. Number 9, what is the area and perimeter of the polygon formed by these vertices? Okay, so I'll do this maybe without sketching, and then I'll show you the sketching if this algebra makes it's a little confusing. So for area and perimeter, we need to find 2 things to start. We need to find the length, and we have to find the width, right? We need to know how long and wide, or to find the dimensions of this rectangle. So we know it's a rectangle. Let's take a look between A. A is -4, comma 2, and B is located at 2, comma 2. So I think we can find the distance between these 2 points so that we find one of the lengths. Okay, so if we go ahead and do that, they're in different quadrants. So what we're going to do is we're going to add their absolute values. So let's take this -4 and +2. The absolute value of -4 is +4, and the absolute value of 2 is going to be 2. So 6 units is going to be one of them. Let's call that the length maybe. And so that's between A and B. And so that's going to be the length. And let's see what else matches. Those are the y's matched here. So let's see if we can find 2 points that have matching x's. Looks like B and C have matching x's. So for B, I know we have 2, 2. We already used that. And for C, we have 2, -2. So if we found matching y's before, we can use matching x's here to find the other dimension. And so we can find the distance between this 2 and -2. So let's go ahead and see if we can write that. We're going to add again here since they're in different quadrants. So 2, absolute value of 2, absolute value of -2. This is going to be 2 units, and this is going to also be 2 units. So 2 plus 2 is going to be 4 units. And that right there will be the width of this rectangle. So if we want to find the area of this thing, we can go ahead and do so. So for the area, oh my goodness. Sorry about that. I'm not sure what happened. So for the area, that's length times width. So the length here is going to be 6 units, and the width is going to be 4 units. So 6 times 4 is going to be 24 square units. That'll be the area. And then for the perimeter here, let's pick a color for the perimeter. I guess, I don't know, I'll just use black here. It's a good one. And so for the perimeter, imagine a rectangle. We have 2 of the lengths plus 2 of the widths. Okay, so 2 of the lengths, so the length we said was 6, so 2 times 6 units, plus 2 times the 4 units for the width. 2 times 6 is going to be 12 units, and 2 times 4 is going to be 8 units. So altogether, that's going to be 20 units for the perimeter. Not units squared, just units, because perimeter is one-dimensional. Okay, so that would be the area and perimeter. And if you wanted to see this on a sketch, because usually that helps people kind of visualize this a little bit more clearly, I'll go ahead and show you this. This will be my y-axis, and this will be my x-axis. Let me go ahead and plot some things. So for A, this point A, it's going to be 1, 2, 3, 4, 1, 2. So here's A. For B, it's going to be 2, 2, so 2 this way and then 2 up. For C, it's going to be 2 to the right and then 2 down. And then for D, it's going to be 4 to the left and 2 down. So where's the rectangle we're talking about? So A to B tells us the length. B to C tells you the width. So we knew that this was going to be 4 units. We knew this was 6. This is 4. This is 6. So if you want to count up the perimeter, go for it. But 6 times 4 does get 24. And then 6 plus 6 plus 4 plus 4 does get you 20 units. Okay. There's 9. Let's take a look at 10 here. What are the coordinates of a point? So they're looking for an x comma y. I'm going to go ahead and write that here. They're saying what are the coordinates? We need an x and a y. So we know that the points or the coordinates are going to be in quadrant 2, but it has to be 5 units away from this point right over here. So let's see, it has to be in quadrant 2. So let's think about this. In quadrant 2, what kind of points do we have? In quadrant 2, for the x comma y, it always has to go to the left, which is negative, then it has to go up, which is positive. So it has to have a negative x value and then a positive y value. And if it helps you see that what's going on here, I can go ahead and do that as well. So we don't need to have a terribly large drawing here. But let's see how I can draw this out. So it has to be in quadrant 2. So what point is this one in? This one right here is in quadrant 3. So let's see if I can plot that for you. 1, 2, 3. And I'll go 1, 2, 3. So it's got to go 3 to the left and 1.5 down. So that's like right here. Okay. And so if we have to say it's 5 units away, well, and it's got to be in quadrant 2. So where's quadrant 2? Quadrant 2 is located up here. So we have to go 5 units away. Well, think about all the ways we can go 5 units away. We could go 5 units this way, but that would go to quadrant 4. We can go 5 units this way, but that'll be still in quadrant 3. If we go to 5 units this way, we're still in quadrant 3. And if we go 5 units this way, then we'll be in quadrant 2. So I think we know which way we have to go. So we can go ahead and count 5 units up. So right here, from here to here, we know that's already 1.5 units, right? Because if we take the absolute value, we know that's 1.5 away. But how far more do we have to go? Well, 1.5 plus what number equals 5? And if you want to say like, okay, 5 minus 1.5, then it'll be 3.5 units. Okay, so we still need to go 3.5 units up. So let's go 1, 2, 3, 4. So where does 3.5 take you? 1, 2, 3.5. I think this would be that 3.5. Okay, so where would the point in quadrant 2 have to be? I think that would have to have the same x value. So it's still going to be at -3, but what's the y value? The y value is going to be positive 3.5. So if we wrote these coordinates down, for this original point P, remember P is located at -3, -1.5. And we now know that this point up here, we think is located at -3, 3.5. We can see if we can find those distances. So I'll call this my P prime, I guess. Or no, I shouldn't call that P prime. Let's just call this a new point. We'll call this Q. So our original point was P, right? So P, they told us, was -3, -1.5. And we were trying to find a point Q, which we found right here, that was in quadrant 2. And I think that makes sense because that's negative and positive. That is in quadrant 2. And they have to be 5 units away. So let's see. These match. So I'm going backwards now just to check. Let's see how far these are from each other. And if you add their absolute values, because they're in different quadrants, let's see what happens here. We're going to add, that's going to be 3.5, that's -1.5, 3.5 plus 1.5 does equal 5 units away from each other. So if they're asking us what are the coordinates of this point in quadrant 2, that's located 5 units away from P, which is -3, -1.5, then I'll call this point Q, the new one. Again, you can call it something else, that's fine. Or you can just say the new point would be, but I'm giving it a name, calling it Q. All right, so there's number 10. Where's 11? There it is. Let's see, let's take a look at 11 here. Given a 3 vertices, so we have 3 corners. 3 corners located at these 3 places determine the 4th and final vertex. So we gave us 3 points and we need the 4th one, which is going to be H. That would complete a rectangle. Then determine the perimeter of rectangle EFGH. Those are just the 4 corners. Okay, so generally it's a good idea to stack these on top of each other. E, F, G, H. H we don't know, so I'm just gonna kind of leave them blank for now and see what you can notice about these. So these are next to each other. They have matching Y's. Okay, so if they have matching Y's, that's helpful. And then you can see that these are matching X's. So that would be another, we could find the dimensions there. And then, so what would happen next is like over here, we would have matching X's again. So we now know that this has to be -5. And for this final piece here, this -5 has to match whatever's down here. So this is going to be -5. Okay, so if they're asking us where would be H located, we're saying H is located at -5, -5. Okay, then it says find the perimeter. Okay, well for the perimeter, what we can do is we can look here. Remember they had matching 4s, so we can just take a look at their these other y values to find the distance here. So we can go ahead and say they're in different quadrants, so we can add their absolute values. So we have this -5 and +3. That's 5 plus 3, so that's going to be 8 units. That's going to be one of the dimensions. And these ones here have matching x's. So I think what we can do is say, oh, this might be confusing. Let me get rid of this. There's a lot I'm drawing here. So here we have matching x's, and let's see the distance between these ones, these y coordinates. And so give me a moment to try to write all this out. We have -5, that's the further one. They're in different quadrants, so we're going to add. That's going to be 5 plus 4, and so that's going to be 9 units. So it doesn't matter which one you call which, but I'm going to call this one the length. I'm going to call this one the width. Okay, so they're asking for the perimeter. So perimeter is going to be 2 times the length plus 2 times the width. So 2 times 8 units plus 2 times 9 units. So 2 times 8, that's going to be 16. And then 2 times 9 is going to be 18. And then 16 plus 18 is going to be 34 units for the perimeter. Okay, to kind of back all this up, because I know sometimes it's confusing to just see the math and not really see like the picture. I think I'm gonna draw the picture here just to hopefully make it a little bit more clear. Again, nothing special, just a rough sketch. For E, that's 1, 2, 3, 4, 5, then positive 1, 2, 3, 4. That's going to be E. For F, it's going to be 1, 2, 3, then up 4. For G, it's over 3 to the right, then down 1, 2, 3, 4, 5. And H is -5, -5. So where is our rectangle? So E to F, we already found that was 8 units across, right? That was 8 units across. H to G is also 8 units because it's a rectangle. That's why we had 2 8s earlier. And then we should have 9 coming down and 9 coming down. So 9 units and 9 units. So for the perimeter, hopefully it makes sense. 8 plus 8 plus 9 plus 9 does equal 34. And for the last coordinate H, hopefully I've also convinced you that this is at -5, -5 in the bottom left corner here. Okay, so if it helps you to make a sketch first, then go for it. But hopefully the algebra made sense as well, or showing it just using the absolute values. All right, moving on to number 12. Consider this point Q. Okay, where is that located? It's negative, then positive, so that's in quadrant 2. Just so we kind of visualize what's going on. It's kind of hard to read that, sorry. Quadrant 2. Write the coordinates, so they really are looking for like an X and a Y of the reflection, okay, of point Q. We're going to call that Q prime across the x-axis. Then write the coordinates, so another xy, for the reflection of Q called Q double prime across the y-axis. Okay, so let's go ahead and write these two down. So we know Q is here. Q is located at -5.25 comma 6. So if we want to go across, I'll call this reflect across the x-axis, then what's going to happen? If we flip it across the x-axis, that means you're flipping it up and down, okay? So if we're flipping it up and down, then the x's are going to stay the same, but the y's are going to be different. So Q prime is going to be -5.25 comma -6. Okay, so just keep in mind when you do that, if you're flipping across the x-axis, the x's stay the same. It's the y's that are opposites. Okay, now let's see if we're going to reflect it across the y-axis instead. So the y-axis is that line going up and down, so we're going to reflect this thing left and right. So if we take this Q, original point of Q, and we reflect it across the y-axis, then what's going to happen? Well, Q double prime, calling it something slightly different, is going to be +5.25 comma 6. So notice here that the y's stay the same, but the x's are now opposites. Okay, let me show you this on a graph. So this hopefully makes more sense, because I know this can be a little bit tricky as well to imagine. All right, so where's my original point of Q? Well, negative 1, 2, 3, 4, 5, 6. So here's negative 6. And then 1, 2, 3, 4, 5, 6. So negative 5.25 is like, I don't know, somewhere here. Just trying to estimate. So for this first one, which is reflecting across the x-axis, here's the x-axis, right? And so you have to see how far away it is here, and you're going to reflect it all the way down here. So here's where Q prime would be. It makes sense this is negative, negative, because it's in quadrant 3. Okay. Now for the second one, we're going to reflect this across the y-axis. So that's this line over here. So you see how far to the left the Q is. So Q double prime is that many units to the right of it. So notice how the x's flip here. So when you're reflecting across the x-axis, flip the y's, those are opposites. And when you reflect across the y-axis, write the opposite of their x values. And that's it, right? So essentially, across the x-axis here, here's the 5.25. You would have like, I don't know, Q prime somewhere down here. And then across the y-axis, we know that is 6 units over there. So then it's going to be 6 units over here for Q double prime. All right, so those are reflections. Okie dokie. That was 12. For number 13, write 4 ordered pairs. So they want 4 of these x, y's. We want 4 of these that are going to be 3.5 units away. Sorry, that was on 2 different lines, so I'll call this 3.5. I'll rewrite it there. From this point right over here. Okay, so we have point K here. So K is located at 3.5. Oh wait, no, sorry. We want to go 3.5 units away. So K is located at negative 1.5, comma 2. So let's see if we can go ahead and identify. We'll have point 1. We'll have point 2. We'll have point 3 and point 4. So if we want to have these points be 3.5 units away from each other, or sorry, 3.5 units away from here, let's see what we can do. We can either go 3.5 units in any of the directions. So let's just start with the x's. If you go up from there 3.5 units, then it takes 1.5 units to get to 0, and then we need to go another 2 units. So that's going to be positive 2, comma 2. But we could also go down. That is to the right. So we also could go to the left. So we go to the left, then that'll be negative, what's 1.5 plus 3.5? I think that's going to be 5, right? So negative 5, comma 2. So again, notice how we just kept these the same here. And so one of them went to the left, right? This one got more negative, and this one got to the right. Notice how this became more positive. And I'll verify this and show you on the coordinate plane in just a moment, okay? So notice how for the ones I just did, I just kept the y's the same. This is just to the right 3.5 units, and this is to the left 3.5 units. So what if we kept the x is the same now? Let's keep this as negative 1.5 and negative 1.5. And let's go maybe up and down. So let's go up and then let's go down. So if we take this number of 2 and then we go up 3.5 units, 2 plus 3.5 is going to be positive 5.5. And let's say we're going to take this 2 and go down 3.5 units. Well, it takes 2 to get to 0, and we have to go another 1.5 below 0, so negative 1.5. Let me see if I can draw a picture here just to help you see it. Let's see. There we go. Easier with graph paper. Okay, so where's K? K is 1, 2, 3, 4, 5. K is -1.5, but it's up 2. 2, 3, 4, 5. -1.5, and then up 2. I think K would go somewhere like right here. And then so let's like kind of verify each of these. So for this one to the right, that's going to be 2 to the right, 1, 2, and 2 up. So let's see how long that is. So this is 1.5, and then this is 2. So 1.5 plus 2 is 3.5. Okay, so that one is to the right. Let's take this one to the left. So that's supposed to be at -5. 1, 2, 3, 4, 5, and then +2. Oops, I'll go ahead and make that a yellow dot as well. So let's see. This is going to be 1 unit, 2 units, 3 units, and then a half. So that's also 3.5 to the left this time. Sorry, it's a little crooked. And then for point 3, we're going to go to -1.5, and then we're going to go up to 5.5. That's like up here somewhere. So let's see, that's 1, 2, 3.5. So that is 3.5 units up. And then for this final one, let's see, we got to go to -1.5, which is to the left, and then go down 1.5. So I need some boxes down here. I think that's enough. 1.5, 1.5. So this takes 2 boxes, 2 units to get to 0, and then another 1. Whoops, I used the wrong pen. Another 1.5 to get down here. So that's a total of 3.5 units down. So we took care of the right, we took care of the left, we took care of the up, we took care of the down. These are the 4 points that are all 3.5 units away from point K. Are there other ones? Sure. If you think about these are as all radii, then you could have infinitely many other points around a circle here. But I'll save that for another day in a different math class. So I guess it wasn't too bad of a sketch. Could have been a little more neat, but freehand. So there technically are infinitely many more dots that are 3.5 units away all along the circle, but you would need to know some other types of math to figure that out. Okay. There's 13. For 14, let's take a look. It says square, BATH, has a perimeter of 18 units. Okay. If you know the location of B and that all 4 vertices are in different quadrants, determine the ordered pairs. So they're looking for a bunch of X's and Y's of the other points. So they gave us B, and we need to find A, T, and H. So, okay, so we have a square. I'm just going to go ahead and sketch a square. And they tell us the perimeter is equal to 18 units. Well, what do we know about a square? We know that all 4 sides are the same. So if we take this 18 and we divide it by 4, that is going to be 4.5. Okay, if you weren't sure about that, I'll show you. 18 divided by 4 goes in 4 times. That's going to be 16 with a remainder of 2. If we want fractions, we can go that way, or to get decimals, which I prefer here, we can add a decimal 0, and bring it down. 4 goes into 25 times, so that's going to be 20 with a remainder of 0. So for this square, we know that the units are going to be 4.5 units, 4.5 units, 4.5 units, and 4.5 units. And we know that makes sense because if you add them all up, you do get 18. So we need to find the other vertices. So maybe for this one, it makes sense to maybe sketch first so you can visualize what's going on. Okay, so for point B, it's going to be 2 units to the right and then 3 units down. Here's point B. Okay, and then all the other points have to be in the other quadrants. So it doesn't matter which ones you make which, but I'll put B here. B is going to be 2, -3, and then I'll do A, T, H. So we have bath, square bath. Okay, so maybe, I don't know, we can go 4.5 units in any direction, really. So let's see, from here to here, this is already 2 units. So I need to go another 2.5 units to the left. 1, 2, 3. That's a little too far. 3. And so where would this be? I need to go 2.5. So that's 1, 2, 3, 4.5. So I think this right here would be point A. So where would that be located? Well, they have to have the same y value, right? Just because we didn't move up or down, we just moved to the left. So let's see what these new coordinates are. We went 2 this way, and then we went another 1, 2.5. So this should be negative 2.5, negative 2.5. If you look at these, how far apart are they? If you add their absolute values, they are 4.5 away from each other. And then let's see, we need to find the next point, which is going to be t. So let's go up here. So this is going to be 3 units up to the x-axis. I need to go another 1.5. So 1.5 is maybe like right here. I'll call this point t. And for point t, we know it's going to have the same x value as a, right? These have to match because all we did was go up. We didn't move left or right. But the y value is different now. So the y value is now going to be, I believe, 1.5. Let's think about that. We went up 1, 2, 3 units. Here's 4 units and a half. So here was 3, and here's 1.5. So that's 1.5 up. And for this last one, let's see. The last one, I think we actually know that this last point has to be right here because it's a square. So it's going to share the same x value. Whoops. It's going to share the same x value as b. Notice how b's x value is going to stay the same here. So I think that's going to stay as 2. So these match. And then for the y value, I think it's got to be the same thing as t because look how it's the same height as t. So t's y value is 1.5. So I think this y value also has to be 1.5. So these 3 other points we had to kind of solve for, A, T, and H. I think we have them now, and they're all in different quadrants, right? So quadrant 1, quadrant 2, quadrant 3, quadrant 4. There's 14. Take a look at 15 now. This one is a little bit to see if you can hang with me with maybe going a little bit crazy with moving this dot around. So see if you can follow along here. If you got this on your own, fantastic. That's awesome. Let's see. So a point is in quadrant 2. So I'll write my quadrants here. Here's 1, here's 2, here's 3, and here's 4. And so we have a point that's in quadrant 2. So I'm going to put it right over there. That's fine. So that's where we started off. Then we reflect it across the y-axis. So where's the y-axis? It's right over here. So if we reflect it, then it's got to be equidistant on the other side. So here's the new point. I'm going to circle it to be like that's my first thing that I've done. Then it is reflected across the x-axis. So where's the x-axis? That's right over here. So we got to see how far it is from here. I've got to go to the same distance over below. So I'm going to show that this is my new location. I'm going to put 2 circles around it to show you that. Took care of step 2. Then it is reflected across the y-axis. So where's the y-axis? It's here. And so see how far it is from it. We got to go to the other side. I'm going to put that right over here. This is the 3rd thing we've done here. I don't know why I decided to circle it, but it looks like a bullseye. Then it is reflected across the x-axis 3 times. Okay, here's the x-axis. If we reflect it once, right, it's going to end up here. So that's 1. Then if you do a second time, it's back down there. And then a 3rd time, it's back up here. So this is 1. I'm already losing track. So here's a 4th circle. Describe the final location of this point. So we've done that. The final location, we can say it's back in quadrant 2. So after all that, it's back where it started. All right, so kind of a silly little problem, but testing your ability to reflect and keep track of some steps here. All right. Number 16, find the distance between these 2 points. So one final problem here. So we have J is located at -43, 64, and K is located at -28, +28. So we need to find the distance, but take a look here. Unfortunately, there's no matching X's and no matching Y's. So if you wanted to figure out the distance between these, you're going to need to use a little bit more advanced math here. And so what we can do is we can find the distance between the X's. So let's see. How should I write this? I'll start here. To find the horizontal distance, what I'm going to do is take the absolute value and subtract these because they're in the same quadrant. So that's going to be 43 minus 28. Now, what is 43 minus 20? I think that's 15. So that's the horizontal distance. And let's figure out the vertical distance. That's between the y's, right? So we can go ahead and take the vertical distance, but because they're in the same quadrant, again, we'll subtract 64, the absolute value of it, minus the absolute value of 28, so 64 minus 28. And I think that's going to be, I'm blanking here, 36 vertical. And okay, so if we know what kind of drawing maybe we have here, if I did a rough sketch, I can show you. It's not going to be drawn to scale by any means. So let's see. J would be -43, +64 would be like somewhere up here. -28, +28 would be like somewhere here. So what did we just figure out? This is like 15. This is 36. If you hear a bunch of kids yelling, they're outside. And so we need to figure out this distance here. I'll call this distance D. And so we know we have formed a right triangle here. So if you recall, we can use something called the Pythagorean theorem, or this is kind of using an abridged version of the distance formula. But essentially what we can say here is if we take the horizontal distance and we square it, and then we add on the vertical distance, which is 36, and then we square it, this will always equal the diagonal distance squared. So kind of a neat little thing that always happens there, okay? And so think about this. What is 15 times 15? You can use standard algorithm, or I've memorized that one. So that's going to be 225. And then what's 36 times 36? I think I have that memorized. It's 1296, if I'm not mistaken, 1296. And again, this is equal to that diagonal distance squared. So adding these two up, we are going to get 1521, I believe. That's going to be equal to that distance squared. And then finally, we should go ahead and take the square root. So I know it's going to be a pretty big number here. So I'm thinking it's bigger than 36, maybe 37. No, that ends in 9. 38 ends in 4. 39 ends in 1. Let me check that on the side, because 9 times 9 is 81, right? So there's only so many numbers it could be. So that's 81. 8, that's 27. 35, that's 27. That's 11. 1, 2, 1, 5, 1. Hey, that's good. So the distance here, or the diagonal, is going to be 39 units. That's how far apart J and K are from each other. So yeah, there you have 16 practice problems dealing with coordinate planes, some integers, some rational numbers, so decimals and fractions a little bit, some reflections, some distances, completing some of these rectangles, finding area and perimeter. And yeah, so hopefully this was helpful, and I wish you the best of luck. See ya.